Okay, today we are going to be talking about the algorithm for dividing fractions and mixed numbers. And we're actually going to be writing two separate algorithms. Your goal is to write down the algorithm and then use the algorithm to help you solve division problems with rational numbers. So we are going to start by simply going to the two different ways that we have for dividing. We've talked about making, for division, to make common denominators. So that would be one method that we have. The other would be to multiply by the reciprocal. So this would be the first method. Our second method that we've used for a couple of weeks, not weeks, but a couple of days, is to multiply by the reciprocal of the second fraction. Reciprocal. Okay, so essentially what we're going to be doing is writing these two algorithms, and then we can go back to these problems, and we should be able to find the answer based upon the algorithms. So I'm going to pull up my algorithm that I have written for dividing, and we are going to talk about them. So the division algorithm for fractions. The first step for both the common denominator, right here, the common denominator method, would be to rewrite any mixed number as an improper fraction, then rewrite any whole number as an improper fraction over 1. So those are the first two steps. Then we can separate between our common denominator method and our whole number, or our multiplying by the reciprocal problem. So first we're just gonna do one of them at a time. So step 1, rewrite mixed numbers as improper fractions. Step 2, rewrite any whole number as an improper fraction over 1. Then for common denominator, our third step would be to find the common denominator between the two fractions. The fourth step would be to rewrite those fractions as equivalents over the common denominator. Then the fifth step would be to divide the numerators. The first numerator is the answer. The second number is the denominator in our answer. And then the sixth step would be to simplify and reduce in the lowest form. So that is the common denominator method. Now if we go to the multiplication of the reciprocal, we would do the same thing as what we did, rewrite mixed numbers as improper fractions, rewrite any whole number as an improper fraction over 1, and then our third step would be to rewrite the problem keeping the first fraction like it is. The fourth step would be to change the division to a multiplication, and then number 5 would be to use the reciprocal of that second fraction. Then we have a multiplication problem when we simply multiply numerator times numerator, denominator times denominator, and then the seventh step is to reduce and simplify. Well, what I'm going to have you do now is I would like for you to get both of these algorithms into your spiral. So go ahead and pause the video for a second, and I'm going to, here in a second, and I am going to put it all down. I'll shrink this down so it all fits on one screen, and that way you can just pause the video and then copy the steps step by step. So let's take a moment and get these down. I'm going to go ahead and shrink them up. So I've shrunk them up. Let's go ahead and get those down into our spiral at this time. Go ahead and pause and get them in. So the common denominator is here. Multiply by the reciprocal over here. Okay, so you should have both of the division algorithms in your fraction, or in your spiral by now. Please make sure that you have written either both of them or the one that makes the most sense to you, as you don't have to use both every time, but you do have to find a way of dividing fractions that works for you. So let's go back and let's take a look at question A. Okay, and I'm going to zoom back in here into the page a little bit, okay? Keep zooming, where's my view? Zoom. All right, and we have, all right, so we're going to come down here to problem A1, and we are going to apply the common denominator algorithm. So for those of you that like the common denominator, I'll be walking you through A1 here. So first things first is we write any fraction, improper fraction as a mixed number, or sorry, any mixed number as an improper fraction. We don't have any of those. And then the next thing would be to rewrite our whole numbers as improper fractions over 1. So 1/3 divided by 9 over 1. The next step would be to find a common denominator. In this case, the common denominator is going to be a 3 because 1 can go into 3 by multiplying by 3. So our common denominator is 3. So this would be 1/3 divided by something over 3. We multiplied the 1 by 3 to get to 3. So we are going to do the same thing to the 9. So 9 times 3 is 27, and that gives us our new numerator. And then our next step would be to divide the numerators, where the first number in our problem, or the 1, is the numerator in our answer, and the second number, or in this case the 27, is our denominator in our answer. And so 1/3 divided by 9 would equal 1/27. All right, so that's the common denominator strategy. For question A2, I'm going to use multiplying by the reciprocal. So we have 12 divided by 1/6. First step is to rewrite any mixed number as improper fractions. We don't have any. So second step, turn the 12 into an improper fraction over 1 divided by 1/6. The next thing we're going to do is we are going to rewrite that first fraction, keeping it the same. Then we change our division sign to a multiplication sign. And then we change the second fraction into its reciprocal, which would be 6 over 1. And then we multiply the numerators together. So 12 times 6 is 72. 1 times 1 is 1. And then we reduce and simplify, so that would equal 72 over there. So 12 divided by 1/6, we'd have 72. All right, and what that means is there would be 72 sixths into 12 wholes. All right, so what I would like for you to do before coming to class is to simply solve the rest of A and be ready to discuss the solutions to those problems. Make sure that you are picking one of the two algorithms that we've talked about in class to solve these with. That way you have something to talk about in class. Thank you.